Hello and welcome back to our series on modeling the University of Greenwich in 3D. In our previous videos, we've covered the overall structure and layout of the university campus, and today we are diving deeper into one of its most iconic features, which is the dome. To make the modeling process easier, we've divided the dome into three main sections, which are the base, the detail facade, and the actual dome itself. To start creating the base of the dome, we will create a compass sketch of 10 by 10. In order to create the base of the dome, we need to use an invisible label in the first extrusion. We will also use a chamfer tool to cut the corners of the base and allow more detail. The outer node of the chamfer tool will be renamed as invisible, and the inner node will be extruded 4 units. Now, using 3D for this project is very beneficial as it saves time, makes it easy to change designs, keeps everything looking the same, and allows for different levels of detail. Due to its non-destructive nature, we will be able to adjust designs easily afterwards, so we can just add dimensions that are closer to the reality. Overall, I think it helps us create the dome and other parts of the University of Greenwich accurately and efficiently. I would like to emphasize once again how important it is to comment your code. It makes it easier to understand for both yourself and others who might work on it later. Comments provide explanations for what different parts of your code do, making it simpler to figure out how everything works. Just remember that taking the time to add clear comments is a key part of writing good code. We will rename the sides of our extrude to invisible, and we will add a polygonal tool into the grid and connect it into the caps output of the extrude node. The number of sides for the polygon will be 16, and we will rotate the polygon by adding 1 unit into the rotate variable. Also, by leaving the triangles variable at 0, we will make sure that the base of the polygon is not divided in multiple triangular faces. This will set the base for the facade of the dome. We created the profile with the shape that we desired for the facade, always remembering that when the segments of the profile are created towards the left, this will result in the geometry going inwards once the profile is extruded, and when the segments are created towards the right, they will go outwards. While creating profiles, it's also important to take into consideration the measurements of the model. Now, this feature is quite similar to the revolve tool in Maya, where you draw a curve that will represent the profile of the surface that you want to create. However, 3D offers the possibility of applying this to any surface. It doesn't necessarily need to be a rounded surface. It could be applied anywhere and modified at any time, which is a great advantage when comparing it to other software. To create the actual dome, we used a pre-made function where you will need to set some variables to indicate the vertical and horizontal distance, as well as the number of partitions. To add more detail to the facade, we will add some columns, as the original dome has them as well. We will create a select node from the sides of the last extrude, selecting the south label. We will also add the rectangle tool, and from the in output, we are going to create a cut node. This will have 2 cuts from south to north, will be parallel to east and west, and will have an exact distance of 0.5 units from the outer edges. The resulting outside areas will be renamed as north. As you can see, the dome wasn't behaving the way that we wanted it to, and that has a very simple explanation, and it's that the variables were not declared. Once that was changed, the dome orientation was also fixed. Finally, We will add another pre-made function where we will specify the column height. We will create a rename node where all faces will be renamed to trim and connected to the wall and trim outputs of our function. I would highly suggest creating variables for almost everything that you use in this project, so it can be modified easily later on. Now, our DOM is ready to convert into a function and import it into the main project, where we will just need to replace the extrude nodes for the function. Our building is a little bit closer to become the University of Greenwich. Thank you very much for watching, and I will see you in the next video.